Here are a few questions from the first unit of electromagnetic theory. If you go through them, you may even answer part B questions too. See the first question. What is Coulomb's law? Q1 and Q2 are the 2 point charges separated by a distance r. The force of attraction or repulsion between them is proportional to the product of the two charges. And F is inversely proportional to square of the perpendicular distance between the two charges Q1 and Q2. Then these two are combined and presented in this form. To remove the proportional sign, we have used the constant 1 divided by 4 pi epsilon naught. If you want to present the same in the vector form, you may write F equal to Q1 Q2 divided by 4 pi epsilon naught r square into r cap. R cap equal to vector r divided by scalar r. Then in vector form, vector F is equal to Q1 Q2 vector r divided by 4 pi epsilon naught r cube. See the second question. Define electric field. An electric field is a region of space in which a charged body can experience a force. The influence can be realized to a certain extent. That region is called electric field. Here a point charge is present. The influence of the charge can be realized to some extent. So this region is electric field. If you bring a test charge, the test charge may realize a force. See the third question. What is electric field strength? The electric field strength or intensity E at a point is defined as the force experienced by a unit positive charge placed at that point. E equal to F divided by Q. Then the unit of electric field strength is Newton per Coulomb. Define electrostatic potential. Electrostatic potential at a point is defined as the work done by the external sources against the direction of the field in carrying a unit positive charge from some reference point to the point under consideration. Suppose the charge Q is present at a point R dash. If you want to bring the charge Q to the new point R against the electric field, work has to be done. That work done is called electrostatic potential. So pi of r is equal to Q divided by 4 pi epsilon naught into R minus R dash. It is a scalar quantity. Give the relation between electric potential and electric field. The negative potential gradient is called an electric field, equal to minus grade pi. The rate of change of potential with the distance is called potential gradient. State Gauss law. The electric flux linked to a closed surface is equal to 1 by epsilon naught times the net charge Q enclosed by the surface. Integral E dot ds equal to 1 divided by epsilon naught into Q. This is a surface integral. Give the differential form of Gauss law. According to Gauss law, E dot ds equal to 1 by epsilon naught into Q. If you use our Gauss divergence theorem, that can change the surface integral into volume integral. That is E dot ds equal to dv dv. Integral E dot ds equal to integral div dv equal to 1 by epsilon naught into q, but q equal to integral rho dv. Therefore, div dv equal to 1 by epsilon naught into rho dv. But the displacement vector in vacuum is epsilon naught into E. If you cross multiply, we can get del dot epsilon naught E dv equal to integral rho dv. This is our d, displacement vector. Div d dv equal to rho dv. Integral del dot d minus rho into dv equal to 0. But dv not equal to 0, therefore div d minus rho equal to 0. From this we can write div d equal to rho. This is a differential form of Gauss law. Arrive at Poisson's and Laplacian equations from Gauss divergence theorem. We know that div equal to rho by epsilon naught, but E equal to minus grade pi. If you substitute del dot minus grade pi, which is equal to rho by epsilon naught, we can get del square pi equal to minus rho by epsilon naught. This is called our Poisson's equation. In a charge-free region, rho equal to 0. At that stage, this Poisson's equation is reduced into Laplacian equation. Here, del square is dou square by dou x square plus dou square by dou y square plus dou square by dou z square. This is called a Laplacian operator. What do you mean by dielectric? You know that insulators don't have free electrons since all the electrons are tightly bound to the nuclei of the atoms. Thus, the electric conductivity of an insulator is very poor. However, the behavior of an insulator gets modified in the presence of an electric field. Insulators whose behavior gets modified in the presence of an electric field are called dielectrics. What are isotropic and anisotropic dielectrics? When the change in the behavior of the dielectrics is independent of the direction of the applied field, the dielectric is known as isotropic. If the change in behavior of the dielectric depends on the direction of the applied field, the dielectric is called anisotropic. Define dielectric polarization. When a dielectric is placed in an electric field, its molecule becomes modified and the dielectric is said to be polarized. In a homogeneous isotropic dielectric, the polarization directly depends on the total electric field in the medium. So the average dipole moment induced in each molecule of the dielectric is proportional to the electric field in the medium. P is proportional to E suffix m. P equal to alpha into Em. Alpha is called molecular polarizability. If there are n molecules per unit volume in a dielectric, the polarization P equal to n alpha E suffix m. Therefore, the induced electric dipole moment per unit volume in a dielectric material is known as dielectric polarization. This is an actual definition. What are polar and non-polar molecules? The molecules of a dielectric are classified into polar and non-polar molecules. The positive charges of the nucleus may be supposed to be concentrated at a point, say the center of gravity of positive charge. Similarly, the whole of the negative charge due to the electrons in orbit may be supposed to be concentrated at a point called the center of gravity of the negative charge. When these two centers of gravity coincide in a molecule, the molecule will have no resultant charge and As such, there is no permanent dipole moment. Such molecules are called non-polar molecules. Examples: O2, N2, helium, neon, etc. Molecules with no permanent dipole moment are called non-polar molecules. Molecules with permanent dipole moment are called polar molecules. See here, polar molecules have permanent and induced dipole moments, while non-polar molecules exhibit induced dipole moments and have no permanent dipole moments. Examples: HCl, CO, H2O, etc. These are all the examples of polar molecules. What is meant by dielectric constant? The dielectric constant may be defined as the ratio of the absolute permittivity of the dielectric to the permittivity of the free space. Epsilon r is equal to epsilon divided by epsilon naught. What do you mean by molecular field in a dielectric medium? The electric field that is responsible for producing a molecule of the dielectric is called the molecular field. The value of molecular field for non-polar isotropic dielectric is Em is equal to E plus P divided by 3 epsilon naught. Give the relation between E, D and P. Here E is the electric field, D is the displacement vector, and P is the polarization. Electric displacement vector D equal to epsilon naught E plus P. In vacuum, polarization P equal to 0, therefore D equal to epsilon naught E. Give the value of electrostatic energy in a dielectric medium of absolute permittivity epsilon. The electrostatic energy in a dielectric medium of absolute permittivity epsilon is U equal to 1 by 2 epsilon E square dV. You know that D equal to epsilon into E. Therefore, this is modified as epsilon E into E. Epsilon into E is our D. This is equal to D dot E dV. What is the SI unit of capacity? The SI unit of capacity is farad. 1 farad is the capacity of a conductor in which the potential of the conductor rises by 1 volt if given 1 coulomb charge. What is the potential energy of a conductor? The amount of work done in charging the conductor is stored by the conductor in the form of potential energy. The potential energy of a conductor is half CV square. Here C is the capacitance, V is the potential. What is meant by capacitance of a capacitor? The capacitance of a capacitor is defined as the ratio of charge on either conductor of the capacitor to the potential difference between them. It's a parallel plate capacitor. C equal to Q divided by V. That is equal to epsilon naught epsilon r A divided by D. Which factors are affecting the capacitance of a capacitor? Area of the plate, distance between the plates, and the permittivity of the medium are the affecting factors. See this formula? Epsilon naught epsilon r A divided by D. This is distance of separation, A area, then permittivity of the medium. Provide the Laplacian equations in one-dimensional and two-dimensional forms. You know the Laplacian equation, del square pi equal to 0. This is in the three-dimensional form. Dou square pi by dou x square plus dou square pi by dou y square plus dou square pi by dou z square equal to 0. If you want to present the same in one-dimensional, y and z terms are 0. If you want to present the same in two-dimensional, z term is 0. So dou square pi by dou x square equal to 0 is one-dimensional. Dou square pi by dou x square plus dou square pi by dou y square equal to 0 is two-dimensional.